Hello, mathematician and the other scientists. Welcome to our study today, whereby we are focusing on ordinary differential equation of first order, and we are looking at how can we solve an equation which is reducible to homogeneous. That equation is of this form, whereby you have d over dx is equal to a1 x plus b1y plus c1. This is divided by a2x plus b2y plus c2. Where a1, a2, b1, b2, c1, c2 are a constant. Now, to reduce this equation of this form to homogeneous, we are going to make the following substitution. So we let our small x to be equal to capital X plus constant h, and also we let our y to be equal to capital Y plus a constant k. You can call this equation number 2. Then the differentiating capital Y with respect to capital X, the result from here will be the same as with respect to small dx. That way. So dy capital over dx capital is equal to dy small over dx capital. You call this equation 3. Then our dy capital divided by our dx capital is equal to, we substitute these values, we substitute equation 2 in 1. We substitute equation 2 in 1 to obtain the following. So instead of x, small x, we are going to have capital X plus 8 plus b1 into bracket. Instead of y, small y, we are going to have capital Y plus constant k plus c1. Everything we divide by a2 into bracket capital X plus 8 plus b2 into bracket capital Y plus k plus c2, which we can write as a1 of capital X plus b1 of capital Y plus a1 plus b1k plus c1, everything divided by a2 of capital X plus b2 of capital Y plus a2 of 8 plus b2 of k plus constant c2. You can call this equation 4. Now, in order now for our equation to be solved, it implies that from equation 4, that a1 plus b1k plus c1 divided by a2 8 plus b2k plus constant c2, this is equal to 0. This equation 5. This equation 5 is solved simultaneously to obtain the values of h and k. So you solve this simultaneously to obtain the values of h and k. Now, our 4 reduces to, so 4 reduces to, so substituting this part here with the 0 and this other one with the 0, we are going to get dy capital divided by dx capital is equal to a1 x plus b1 capital Y divided by a2 capital X, then you want plus b2 capital Y. You can call this equation 6. Now, equation 6 is homogeneous equation. It is a homogeneous equation of degree 1. So, we make the following substitution to solve it. We let our y to be equal to Vx. Then, of course, here we differentiate this both sides, dy small y over dx is equal to v plus x dv over dx. Now, you call this 7. Then, of course, you make this, you compare 7 with the 6. Bearing in mind that our x, small x, is equal to capital X plus 8 divided, and our y, small y, is equal to capital Y plus k. Now, the result which you obtain from equation 5, you use them to substitute. You use them to substitute them here, so that now you can get the value of x, small x, in terms of capital X and constant h. You get y in terms of capital Y and constant k. So that is how you reduce an equation into homogeneous by making this substitution. On an example of this kind, remember to tune on to my YouTube channel so that you see how a real practical example is done, which I'm going to present to you in the next video tutorial. For further such working on mathematics, particularly on online differential equation, calculus 1 and calculus 2, kindly check in my YouTube channel so that you may learn with me and the other mathematicians on how to solve equations in a simple step method whereby we simplify mathematics for you. Bye bye. Remember also to subscribe to this channel and also to share with the other learners. Also, you can give your comment in the comment below so that I may see on how you want to improve on the same.